All right, this is torque, which is a twisting force, right? So if you've got some center of rotation there, and you've got a force like this, and this is our R, right? That it's the R times the force. If the angle is not exactly 90 degrees, sine of 90 would be 1, right? Okay, if it's a situation like this where we're rotating from there, and then we've got like that, right? It would be this angle right there. So always place them. What you want to do is place them tail to tail and find the angle between them, between R and F. So be careful there, right? This is moment of inertia. This stands in for inertia or mass, right? Of inertia. And they show it as the sum of whatever. Typically it's something like I is 1/2 mr squared for a cylinder. Do you remember this? 2/5 for a sphere, right? And they've got a bunch, so they'll tell you what the moment of inertia is, and that's what stands in. This is the rotational version of F equals ma. So this is, of course, angular acceleration. That's radians per second squared, right? Moment of inertia is in kilogram meters squared. Torque is in meter newtons. Whoops, I wrote it exactly wrong. Meter newtons. Okay, and then omega is 2 pi f. So say you're going around once per second, your frequency would be 1 per second, right? So your angular velocity would be 2 pi times 1 per second, so 2 pi per second, right? If your frequency is 2 hertz, right, 2 times a second, then it'd be 4 pi would be your angular velocity. So that's angular velocity. Right? And then this is This is V equals U plus AT, which I tend to just use this. This is V squared is U squared plus 2AS. So we're Suvotting here. This is S is UT plus 1/2 AT squared. The one that they don't give you, which you could just use, right, is S is U plus V over 2 times T, right? You could use that, right? So the alpha is your acceleration, T is time, theta is like displacement. Remember, this needs to be radians. This should be radians per second. Okay, and I don't think they're going to give you RPM conversions. I don't think people in Wales know that there's people in America using revolutions per minute, right? Maybe there are. And then this is angular momentum. Right? And that's just basically the linear equivalent is P is mv. It is conserved, okay, despite what some people say on the interwebs, right? It is definitely conserved, and so this will lead you to problems where you're going I1, omega 1 is I2, omega 2, right? And then this is our rotational kinetic energy, so 1/2. This is the linear version of this is EK is 1/2 mv squared, right? Okay, so this stands in for m. That's our velocity, and it all works. Okay, yeah. I don't know. I guess I'd try some of these problems, I guess, before I sat down and took the test.